Hello everyone, my name is Philip and I welcome you at the third tutorial from the tutorial series called the Development of Algorand using Raspberry Pi. So, where do we start? So firstly we a little bit touch the motivation, what is our target in this tutorial, what we want to achieve. In the next part we cover the public key cryptography briefly, touching the digital signatures and later on the application in our corresponding steps. Finally, we also provide insights into the types of accounts which are available in Algorand networks. And finally, we go through the demo where we prepare the parts covering the first signature of our transaction in an offline manner and later on issuing the transaction itself using the JavaScript SDK provided by Algorand networks. So, why do we actually care about this part? So, as you might have heard, in many blockchain networks, actually private and public key pair are the form of our identity. So in case we want someone to send us some tokens or some other coins, what would we share with them is the public key, which actually is the address which they know how to contact us. And on the other side, we have the private key, which actually we have to really protect because this means that this is basically binded to our identity. And with the private key, we are able to sign new transactions and we are also able to participate in the consensus algorithm in our case. So therefore it's really essential to protect this private key because in case someone steals from you this private key or you lose it, you basically lose the access to your kingdom. And in our specific case for this tutorial, it's really important to use the private key for the signing of a transaction, where we of course can talk about arbitrary transactions, which is fine, but for our specific focus, we focus on the key registration transaction, which is important in the part of running a node in the network, where in case we want to have an online and active node, we have to regularly generate participation keys, and in order to register this participation key in the Algorand network, we have to issue so-called key registration transaction. And of course, same as any transaction, we have to sign this transaction using our key. And therefore it's important that we do this in a secure manner, and that is the part where we basically dive into the signature of this transaction in an offline manner, meaning that we can do this without being connected to the internet, so the attacker cannot really actively expose the private key usage at that point. And we will be using for that JavaScript Algorand software development kit, or so-called SDK. So what is a public key cryptography? So in public key cryptography is the main paradigm that we have a public key, which everyone knows, and we have a private key, which is we have to store with us. So therefore we really have to keep this private key protected, and we can publish our public key to whomever we want. So actually it's something what we want to do as well, because in case we don't publish our public key, no one can really send us any algos, and this is not something what we want. And public key in general can be used for encryption and also signing, where for the focus of the tutorial and in general most of the application in blockchain we are using public key cryptography for the signing. And signing has this nice property that we sign certain data with our private key, and anyone else can verify that this data were signed by us. Which guides me to the next slide, which is so-called digital signatures. And digital signatures have three main following properties. First is data integrity. So in case that I create a transaction, I sign it with my private key and I share it with others. In case someone would like to modify this transaction, meaning that, for example, he changes the transaction which I'm sending, how many algos I'm transferring from someone to someone, and he wants to change this field, it's not possible because basically with the signature which I create, we ensure the data integrity, that no one can really modify that this data on its way. Second part, which is really important, is also data authenticity, which means that anyone who has my public key knows that I, as my identity, private and public key, am the one who actually signed the corresponding data. And this is also something what we know, that everyone knows that the data are coming from me. And finally, non-repudiation in this context means that I cannot disclaim that I have signed the data. So it's also on the other side that no one can really be around and trying to see that, hey, I'm the one who signed the data on your behalf. It's not how it works. It always means that I am the one who is responsible for the data I have signed. And diving into the next part, I believe some of you have already heard about RSA signing scheme, which was really widely adopted in many systems. But currently we see the transition from RSA-based systems to elliptic cryptography, which is most to the part where actually the RSA is a little bit bulky in the sense that it has too large keys, and also this means that it generates too large signatures, which of course in such a large system where we have millions of signatures running in the network, we care about the size because of the scalability part, and that is the reason why we use elliptic curve cryptography. And namely in Algorand network we see the Edwards curve 25519, which is offering really good security, small private key, small public key, and also generating small signatures. As I was mentioning in this tutorial, the main focus is that in case we want to participate in consensus, we need to generate a participation key, which later on, in order to basically propagate this information to the network, we have to issue so-called key registration transaction. And of course, as any transaction which we want to send from our account, we have to sign this transaction using our private key. This operation of signing has to be, of course, done in a secure manner, because in case someone compromises this operation, it's possible that they could get to our account, and later on the node could actually misbehave or be marked as malicious. We focus therefore on the part of doing the signing of the corresponding key registration transaction in an offline manner using JavaScript SDK. And before we dive into the demo of the corresponding stuff, we will also briefly touch what type of accounts actually are in Algorand networks for the development and in general also for the running of the nodes. So we have two main accounts. One is called volley derived account and the second one is standalone account. And the main difference is that the standalone account we generate once, and we basically right away see the corresponding private and public key, where the private key in this case is the part which we are most of you familiar with, which is this 25 word format, which is basically used later on to derive the private key using the private key derivation function. And on the other hand, the key management, which is basically running under the volley derived account, requires so-called key management daemon or KMD, which basically stores and operates permanently on the node. So this of course has also the impact on the required performance, and also in case we have a constrained device, it's recommended to use the standalone account, which basically you just generate once, and on the other hand the key management daemon has to run for the case of the volley derived accounts. And this basically goes to the part of the way how we treat or how we, for which application we use this different type of accounts. So for the volley derived account, in case we want to have multiple accounts, we basically derive only a single master key, and from this master key we are later on deriving different private keys. Important to mention, it doesn't mean that the successive private keys which are being generated are insecure, but because we of course have the assumption that no one can really brute force and find in a reasonable time frame the key which was derived from the original master key. So it makes it basically secure, and we heavily rely on the volley derived accounts during the development on Algorand network. On the other hand, the standalone is basically used once, generated once, and it's later on very useful for the part of offline signing. And second big difference between these different type of accounts is that the KMD is creating the private and public key, and the private key are stored actively on the disk in an encrypted form, and when we want to use them, we basically have to provide the passphrase to decrypt the private key and to basically use them for the signing. And on the other hand, the standalone is basically not stored anywhere, and it's just basically used once we want to use it, and we have to always keep in mind this 25 letter passphrase for the purposes. And in our tutorial, we'll be basically using both of these accounts. So our node is using the KDM type of account, the wallet account, where we just generated it once and we know it's stored in a secure manner on the disk. But in case we want to sign a new transaction in an offline manner, we will use the standalone account for that purpose. In the tutorial, we will need some dependencies. So in case you haven't installed them yet, I strongly encourage you to navigate to the tutorial part 2, where we discover the steps required to install those dependencies. Then I will show you a small script which I have made to automate the participation key generation. Next, I will introduce how we can sign the transaction in offline manner using the JavaScript Algorand SDK. And in the next part, we submit our first transaction using the JavaScript Algorand SDK. And finally, we have to keep in mind that before participation, we want to keep the key secure. And with that, I would like to close the first part of this tutorial.